real name is Hamish. Let's go. So limit. I don't want to waste no time. So let's say here, state the following below is either true or false. And if it's false, write the correct statement. Okay, let me explain to you limit quick, 1 minute, and there we go. So if somebody say, for example, limit, let's say x approach to, let's say 2, and here they give you x, let's say 2x. So what does that mean? Meaning, okay, when they say approach 2, I'm gonna make it easy word that you can understand. So I say approach 2, make it 2. So now when they say x approach to 2 means make this x equal to 2. So if I'm gonna make this x equal to 2, I don't have to write it again. So this is gonna become, I don't have to write limit because I make it this x equal to 2. So it's gonna be 2 times, instead of this x now, because it's x approach to 2 means make this x equal to 2, I'm gonna write 2. I don't have to write limit again because I have already made it x equal to 2. So no limit, don't write this again because you have already replaced this x with this number. So this equal to 4. So that's how limit works. Just one more example. So somebody give me limit, let's say 3 over x, and I'll say limit 3 over x, and let's say this x approach equal to 0. So we got problem here. You know what the problem? Look, if I'm gonna come and replace the limit, okay, let's put in the limit. Means this is gonna be 3 over, instead of x, I'm gonna say 0. But any number divided by 0 is undefined. You know what I'm saying? It's undefined. So for that case, this limit does not exist because you see, there's nothing. This is undefined. So you say limit does not exist. So here, limit doesn't exist. Doesn't exist. You know what I'm saying? So sometimes they will give stuff like this. For example, limit. Just one more example. Limit. Let's say 2 minus x, and they give here 2 minus x. No. Excuse me. Let's say they give you stuff like this. Let's say limit. Let me use a color quick. Limit, and they give you here x squared plus 4x plus 4. And here the denominator, they say x plus 2. But they say x limit approach equal to -2. So now sometimes do not substitute limit before you simplify. Because if you substitute right now, we're going to be a problem. Look, if we take this, so first simplify whatever you have here, then after simplify, and then you insert your limit. For example, here, look, when x equal to -2, what it's going to tell is going to be, doesn't exist. Because look, if you don't simplify, that's where you get yourself in trouble. Look, so this is going to be, oh, if I put 2, it's going to be 4. If I put 2 times 4 equal to 8, because, okay, now, plus 4. And if I put -2, excuse me, -2 equal to 4, and this -2 is going to be -80, and therefore, if you put -2, it's going to be -2 plus 2, and this is going to be number, which is 0 over 0. You see? Which it doesn't exist. You know what I'm saying? It's undefined, or you call it undeterminate sometimes, or doesn't exist. You know what I'm saying? So you see, you find like, oh, it also doesn't exist. But no, it does exist for this case. So I would encourage you, don't insert your limit before you simplify. Look now what we're going to do. So simplify. Okay, now let's look at it. So what I'm going to do here, I know if the numerator I can simplify. This is going to be x plus 2. If you factorize it, this is going to be x plus 2. And this is going to be x plus 2. So you see, this and this cancel. Oh, but we still have our limit. The limit has not gone yet. It's still there. You know what I'm saying? -2. You only don't write after you have substituted. So now, what we get here, see, this and this cancel because they're equal. So you still have your limit. X approach -2. And then here on top, you have x plus 2. You know what I'm saying? And then now we're going to substitute. So when you substitute now, substitute our limit. So this is going to give us, what is the limit? -2 is going to be -2 plus 2. Don't write limit again because you have already substitute. You have already set your limit. So this equal to 0. You see, it does exist. Equal to 0. So don't substitute the limit before you simplify. You know what I'm saying? Now let's go to the rules now. So here's like a rules, but I'm going to explain you in terms of the mathematical way, so you make a lot of sense. Now, you know what I'm saying? So now, so let's take some rules. I believe you have a little some understanding, like how the limit works. Okay. So now let's take this some of the limits here, man. Okay. So let's say here, when you, this is true because if you substitute here, it's going to be f of a. It's true. Just like the first example with D. So now let's take example quick. Yeah, the first one is true because if somebody give me, let's say A. Oh, excuse me. Somebody give me Okay, limit x approach to a can be any number, let's say -3, and then f of x, okay, f of x can be anything, let's say x or x squared. So what happened? If we want to substitute here, it's going to be f of a. What does that mean? This is f of x. So if I substitute -3 here, it's going to be -3. I don't have to write this limit again because now you insert your limit. It's going to be -3, but what? Square normal limit. So you see, this f of x, but this f of a. What does that mean? Our x now is -3, and instead of x, we put what? We put a. You know what I'm saying? This x is -3, so we substitute here. It became what? +9, which is +9. So +9 is f of a. So this is true, like f of x, da 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 da. Okay, now let's go for the second question of addition and subtraction. So this is true. You see, no more limit. There's no limit, means you got to go to 9. Da da da. Okay, if you have any question, you can leave a comment. Okay, now, example number 2, question number 2. So question number 2, or another rules, we say if somebody give you a limit, somebody give f of x limit, so limit here, limit, let's say x approach to, this is x approach to any number, let's say k or a. If we plus the limit, let's say plus g of x, okay? If these are together, you can separate them. It is plus or minus. So you're going to take limit of the first one plus limit of the second one. So it's going to be limit of the first one, and we still have our limit x approach to a, any number can be. So we plus because this is plus. Limit x approach to a of g of x. Sorry, my space line of g of x means of this. For example, let's see. If somebody give me stuff like this, let's say limit, let's say x approach to 2, and here they give me x squared 3, and then plus 4x plus 1. So we want to see if we want to substitute here. So we want to see the rules work. The rules, yes, does work. So means we want to see whatever we're going to get here, is it going to be the same with if I'm going to take separately, like x approach to 2 of the first one plus limit approach to 2 of the second one, which is 4x here, of the second one, whereby x approach to 0, also be limit for each one, and limit x approach to 2 of the last one. So let's find the top one and see if it's going to be true with the second one. Means, so the rules say you can separate, it's acceptable. Let's see if it's going to be true. Now let's go. X equals 2. Okay, you're going to put 2 here. So it's going to be 2 squared equals 4. 4 times 3 equals 2, 12. Plus, now you come here, x equals 2. 2 times 4 equals 8. So it's going to be 8 here. Plus, you see, this one here is not going to have any effect here. You know why? Because there's no x. You know, there's no x here. So it's going to remain the same, it's just 1 plus 1. You know what I'm saying? There's no x. Or in other way, you can say, okay, let me introduce x. If I had to introduce x here, I'll say it's 1 and x power 0. So if I had to introduce limit, because x power 0 go to 1, so it didn't cause any harm or any problem, because it's like same as a 1. But I introduce x just in case if you want to say, oh, so what you mean doesn't have an effect. Now let's look. If we're going to put x equal to 2 here, it's going to be 1 times, is 2, right? 2 power 0. Is 1 times 2 power 0 equal to 1. It's still 1. That's why it's not going to have an effect, because there's no x there. Now, so for that case, that's why it's in mind 1. So this is going to give 20 plus 1 equal 21. So the top one equal 21. Now let's go for the bottom one. So for the bottom one, let's go now. We say we separated each one. So this is going to give us, okay, now put 2 here. So we have another bruising limit. You know, it's not necessarily but very, very important. If you have a constant, you can take behind. I don't know how you call it, behind or front, like before this limit. You can take it behind. They have that rules. You know what I'm saying? So here, you rather take 3 out first, and then you say your limit before you substitute. Limit, you have x squared, x approach to 2. Here also you have a constant. It's not mass, but it's very, very important because it's one of the rules. I'll take it out, it's going to be 4, limit. And they'll have x approach to 2, and then here it's going to be x plus, here just a constant, so you leave the how it is. 1 x approach to 2. Anyhow, it's going to be 2. So now we come here now. Okay, now let's go and substitute. So when you put 2, it's going to be 4. So when you substitute the limit, don't write the limit again. So it's going to be 3 times, put 2 here, 2 times 2 equal to 4. So don't write limit because you insert your limit. It's like now I'm doing it now. So 3 times 4 equal to, so 3 times 2 times 2 equal to 4. Because 2 square. Plus, this is going to be 4. 2 is going to be 2, 2 here. 2 times 4 equal to 8. Okay, 2 times 4. So say 2, 4, this is 2. Excuse me. What am I doing here? 2. Now we come here. This is going to be 1 because no effects. So this is going to be 12 and plus 80 plus 1 and this is equal to 21. Same thing. So the rule does apply. It means if you have a plus or minus, you can separate. But the problem is here is not correct because if it's minus, it must be minus. Excuse me. And they put plus, so this is not correct. So how are we going to correct? We're going to write this equal now. Let's correct now. Okay, so what we're going to do, let's correct, because they say write the correct segment. So to write the correct segment means this monster here is going to become this baby monster. We're only going to change and write plus. Okay, cool. So let's change. So this should be limit, and limit must be the same. You know what I'm saying? Means if this x power, it must x power. Limit. Excuse me. Sorry. It's gonna dry. It's a minute, right? Because I use some. You kind of wait a little bit. You know what I'm saying? Okay. So this means it's gonna become. Okay. So it's gonna become limit. X approach to a means it's a correct statement. X equal to a. You can say f of x. And the minus, it must be minus also. Limit must be the same limit, right? Means this limit to the first one and the second one. But there's a minus, there's a minus. If it's plus, you put plus. Limit of the. Okay, the second one, g of x. G of x. So this is the correct statement. So you can say this is a correct statement, and this is not true because of this baby here. Baby problem. You know what I'm saying? So this is a correct statement. Correct statement. And this one we know it was correct. Okay, now we go for the third one. The third one is not true. You know what I'm saying? It's division. Now let's go for division. So even if it's just plus, we're going to say plus. Now let's go for division. So for division, I think we did it already. A little. Okay, so for division, so if somebody give you, let's say limit, let's say exact, f of x over g of x. Okay, let's say limit x approach to any number. You say a, b, c, d, b, can be any number. Let's say x approach to c for them. So this same say you can take limit of the top separately, limit of the f of x over limit of the g of x, whereby this x same thing must approach c and this x also must approach c. So if you look careful, this is wrong. It don't even make sense. Where a come from and where this come from now. That's a radish. You know what I'm saying? You know what I'm saying? No such a rule. Okay? So now we go. So this is the correct statement. This is a correct statement here. But you have a condition for this. You must have a condition. This stuff here should not be equal to 0. Excuse me. Oh my gosh. The g of x should not be equal to 0 because it's division. You know what I'm saying? So this g of x, but this g of x should not be equal to 0. Now, you know why? Because whenever you have equal to 0, what happens? You're going to have fx over 0. And fx over 0 is, it doesn't exist. You know what I'm saying? Because you don't need 0 at the denominator. Whenever 0 is at the denominator, means undefined. It doesn't exist. Yeah, it doesn't exist. So for that case, this is true, but this should not be equal to 0. So this is correct statement. You can say here, correct statement right here. So this is not false. So you can say this is false. So this is false, and this is a correct statement. And this is false also. False, this is a correct statement. You know what I'm saying? So we have correct already. Okay? Okay, let's take example so you can write that we correct already. Let's take example, for example. I want to raise this because now we know. Okay? Because we need to have space here, you know? For example, somebody gives you a limit x equal to -3, and here they give you, let's say, x plus 6x plus 6x, let's say, plus 9, let's say, and here they say x plus 3. Yeah, x plus 3. So now you see, this is division, means you got function, same limit, like this divided by this. So we know for fx, this should not be equal to 0, because if it's equal to 0, we're in trouble, man. It's not going to exist. So we're going to say, oh, so this stuff here, first and foremost, it could be valid, but first of all, you can see if you can simplify, you know. So this can be simplified, you know what I'm saying? Yeah, no, this is easy. Okay, let me explain to you quick. This is easy because this only can be simplified. You say x plus 3, and this is going to be x plus 3, and here you got x plus 3, so this and this cancel. Limit x plus 3, and you have a limit x equal to -3. Put -3 equal to -3 plus 3 equal to 0. So this is not like, it's like division, but when you simplify, it's not division. Let's just bring the actual example when it's like division. For example, let's somebody say 5. So you know, for 5, you cannot simplify this to get 5. Means it has to remind you how it is. You know what I'm saying? So this, let's say this is 5 here. Let's say this is -5. You know what I'm saying? Let's say that's -5. So now we say, okay, so we say, this one here, there's an issue here, because if you simplify this, there's nothing. There's no number that you can simplify can cancel with the denominator. So for this case, now we say, oh, okay, now let's go. So now, I know if division, the denominator, so denominator means denominator of x, or denominator of x, it should not be equal to 0 for this to exist. What that means? What denominator of x is x plus 5, we know should not be equal to 0. So it means x should not be equal to -5, you take over. Also, x should not be equal to -5 for this limit, which is limit, you say for limit of x minus 5, x squared plus 6x plus 9x plus 2 to exist. Otherwise, it's not gonna exist. Now, let's solve now. So we're gonna say, oh yes. So for that case, I can just substitute my limit, but we know it should not be equal to, we say it should not be equal to -5, because so for that case, this limit does not exist, because they give you now -5. So if they give you -5, this limit doesn't exist. But if it's not gonna exist, you know what I'm saying, if this stuff equal to -5, so to exist it has to be any other number but not -5. For example, it could be -4. Yes, let's put -4 for example. Then, 5 or 6. So it's going to be, if you put 1, let's say 1 is going to be 1 square. Plus 6 times 1 equals 6. No, I'm wrong. You cannot substitute the limit if you still have a limit here. Means if I put my limit now, let's say limit equal to 1. I don't have to write limit again. So it's going to be 1 square equal to 1, plus 6 times 1 equals 6, plus 9. Okay, now 1 plus 5 equal to 6. Don't write limit when you substitute. Means like you say, make it that number equal to 1. So now you plug in the calculator and you get your certain value. What do we get there? Okay, this will be 7 plus 9 equal to 16 over 6 by 2, 8 over 3. Okay, so I think you have an idea. So we know for this limit to exist, like this one does not exist because they say limit, make it -5. When you put -5, it's going to be something over 0, which is undefined. That's what we have to say in the condition of division. What I have said before, this should not be equal to 0. So you had answers already, I didn't draw. Now let's go to the next question. Okay, you know what I'm saying? So for this one, should I write again or you got it? It means you say it must be limit x approach to c of the top one, and then limit x approach to same limit g of x, whereby the condition, we know the denominator should not be equal to 0, whereby g of x should not be equal to 0. Excuse me, my pen is finished. Go out of here. You know what I'm saying? Okay, take my light on. Okay, so it means the denominator should, I'm sorry man, the light should off a little bit. So this denominator should not be equal to 0. Now, let's go to the next one. So for the next one, we'll do the same game. So this, yes, is true because you take the first one, the limit of the second is multiplication. Yes, is correct. This is correct. Because so this is correct. You may take the first one times, because limit of the first group times means here there's a times limit of the second one is correct, because you take 2, you multiply with the same limit. So if they could have changed this, let's say this equal to 5 or to C, you don't know, it's not true. You know what I'm saying? But since the same limit and its multiplications, like to take this for the first group and limit of the second group. Yes, it's true. You know what I'm saying? It's true. True statement. This is not true statement. Now I'm going to show you now what that means. But this is not true statement. Let's make a space here. Okay, cool. Now let's go for the next one. Thank you, thank you, thank you. Excuse me. Okay, cool. Now let's go. So this is not true. You know why it's not true? Where this negative 1 comes from. If somebody give a limit, let's say x equal to a, any number could be x equal to a, and they give f(x) or f(x) power n, let's say stuff like this. Stuff like that. You know what I'm saying? So that means this MSA, you can take this limit, you can take this n outside. You can say this limit, and then x approach equal to a, and then this can become f of x, and then you can say take n outside. The limit is acceptable. But this don't make sense. There's no such a thing where this comes from. So this is wrong. So it's not equal. So say, oh, this is false. And this should be true. What you do, you take this n, put big bracket, you put outside. That's all. For example, somebody gives stuff like this. Let's say limit. This f of x n is like, let's somebody give you x approach equal to, let's say, negative 1, and let's say 2 x power 2. So what that means? This MSA, I can take 2 out first. Take 2 out first, it's going to become 2 limit. Let's approach to negative 1, and then we have an x. So you can take this out completely. Power n. Acceptable. You know what I'm saying? So now this MSA, now let's say it's going to be 2. If you put negative 1 here, it's going to be negative 1. Oh, forgot. Oh, yeah, negative 1. And what is our n? Excuse me. Our n must go out, which is 2. My apology. Oh, you got 2. There's no n here. Means this. Take 2 and then 2. So this will be negative 1, and then after you get your answer, you square. Okay, now we get 2. Negative 1 square equal to positive 1 equal to 2, which is same as this. Positive 2, I could have substitute straight here. I mean, this is like this, and this is like that. So I could have substitute straight to say, oh, my x equal to negative 1, which is going to give me 2. No, right, when you substitute the limit, don't write the limit again. Negative 1 is going to be negative 1 square equal to 1. Or you can say negative 1 square. 2 times 1 equal to 2. You know what I'm saying? So yeah, so this is false, and the correct statement should be, so this is false, but the correct statement is this one here. Means this is going to become limit fxn, and then power n x approach equal to a, and you're done. You know what I'm saying? Done. So that's how you get it, man. Okay, so now let's see some few more limit rules. Some few more limit rules. Okay. Okay, few limit rules. Let's check what happened. Okay. This is constant. X approach to. Do you have X here? No. Like what I say here is like somebody give me let's say limit C. Okay, C. And then X approach equal to A. So now do we have X here? No, we don't have X. Means this is not gonna have any effect there. So we're gonna still have a C because if you substitute here, no substitute, so it's gonna say the same. It's like saying limit C. Since there's no X, you can say X power 0 because X power 0 equal to 1. It's like C times 1, which is C. So this is the same as that. If, just in case, if you want to introduce your A, so you're going to say this equal to, let's substitute the limit, X equal to A. It's going to be C times X equal to A power 0. C times 1 equal to C, because A number power 0 equal to 1. So, but you don't have to write all this, you can just say, because there's no X there. You know what I'm saying? So this is the first one. Let's go for the next one. So for the next one is easy. Come on, man. Take A, substitute here. If you substitute A, it means it's going to be limit. Instead of X, you put A. Yeah, we have X or A, so this could be A. That's all. Know what I'm saying? Let's count for it. For that one. Okay? For this one here. So we say we have a limit X power N. X power N. Whoo! Your pen, where you falling? Bless! Limit X power N, limit X equal to A. So what you get there, look, put your X equal to A, means this is going to become A power N. You know, so that's how it's going to become. For example, now let's put this number, let's say, okay, let's put it like this so it makes a lot of sense. A can be any number, you know, let's say X power 2, and then say AX approach equal to 1. So there's two conditions when this equal to positive and when this equal to negative. Now let's go. So when you put this equal to, so if this, okay, now let's go. So there's going to be, let's say this equal to 2, or any number doesn't matter, so, or 3. So when you insert your limit, it's going to be 3 square, because this is going to be 3 square equal to 9. But this is a different case when this equal to negative. Because when it equal to negative, it's going to be limit. When you substitute, let's say, if this is equal to limit, X negative 2, and then we have X equal to 3, what happened? Look. So let's say change this to negative, like they give you like this. So we're going to say substitute there, it's going to become 3, negative 2, which is going to be 1 over 9. Or 3 square equal to 1 over 9 when you reciprocate. So we see if this number, we call it n, if this n is positive, so what happened? You're going to get all this limit positive number. But if this n means whatever number here we have is negative, means everything is going to be what? Less than 0. You know, that's what I say here. If this, when n is positive integer, if this is equal to positive, what would you get? You get this. If this is equal to positive, you get this. But if this is negative, we get the number between, like smaller number, because you have to reciprocate. It just, they play around with it, you know, with literature right now. You know, we're not in literature class. What you do, just put actual number. Like, okay, let me put a positive number here. Let me say this 5, like what I did, and then play around, okay? And then you can see what I say here. Same here. What I'm gonna do, I'll put my A here, because X equal to A. Put my A, what happened? N. They say N is positive, so you test maybe this is negative 3, you know? For example, so if somebody gives, let's say X, or this is for even, right? So for even, no, so it's 2, let's say, or 4. So X equal to A is limit, let's say X equal to 2. Approach equal to, excuse me, I say equal now. So put there, it's going to be, 2 is going to be 2, and then it's going to be square root of 2. Which you know when you put in the calculator, you're going to get positive number. Okay? You're going to get positive number. But, if this is equal to negative, you know, that's what they say here. If n is positive integer, when n, okay, they say n is positive integer when n is even. When n is even, you see we get positive integer. Let's say here 4, excuse me, let's say this is 4. Let's say this is 4. X of 4. Means you're going to get what? 2. Let's say, for example. Because integer must be like 1, 2, 3, 4, 5, 6. So I'm trying to go with the flow. But I don't think all the time must be. No, I'm wrong, man. Let's leave 2. They talk about the n. N must be positive integer. If this is positive integer, or an even number, let's say 2, 4, 6, 8. it's going to give us, like for this case here, it's going to be, put 2 here, it's going to be square root of 2. Put the calculator, the blah, blah, you're going to get 1 point something. Okay? Now, let's go to a situation whereby, let's say you have a 3 limit. You got x here, whereby limit is x approach equal to, let's say, okay, let's say approach equal to 2, negative 2. So what you're going to get here, we want to see when this is not even number, when this is equal to odd. We want to see what's going to happen here. Okay? If you put odd here, it's going to be, negative 2 is going to be negative 8, because negative 2 cubed equal to negative 8, and then you have a cube root. So you have already put the limit, no need to write the limit again. So this is going to give us negative 2. So you see now, the answer become, so if it's even, something which come here must be positive, but for odd it depends. It could be positive or negative. That's what I say here, when n is positive integer, when this is a positive integer, and then we assume this is greater than 0. They assume this is greater than 0. You know what I'm saying? They assume. So it's like you can put whatever number you want, like try to play around there, you know. They say, we assume this is, because this is like a, it's positive, means this is going to be positive number after you underroot. But I feel like when they say positive integer, where we assume a is greater than 0. Yes, a must be greater than 0, because when you say this equal to 2, when you square root of 2, because substitute x equal to 2, let's say 2. Put 2 here, it's going to be square root of 2. Square root of 2, you know, the answer is going to be greater than 0, because when you square root 2, you're going to get 1 point something, means a is greater than 0, means whatever number is here is greater than 0. But if this stuff is like odd number or whatever, you try, don't look by sentence. We assume x is greater than 0. You see, you don't want to understand. Plug it in. So, for example, let's say they talk about positive integer. Let me put odd integer. Like me, I put odd integer. Say x equal to negative 2. I'm going to put negative 2 is going to give me negative 8. And this is going to give me negative 2. And you see this number here, a, it became less than 0. So it's all depends what you have it in here. This is another one, another rule. So what you do for the last rule, if you have a limit with the square root, you can put this limit inside the root. You see, I take this limit, put inside the root, acceptable. You know what I'm saying? And now they come up with the same story here. If it's even, this is going to be positive. If it's even, if this is even, it's going to be positive. But if it's odd, do the test. You know what I'm saying? Yeah, so that's what happened. So what you do for here, take this limit, put it in. Inside the root, put the limit inside the root. Easy, man. For example, somebody gives stuff like, I think you understand what I'm saying here. I believe so. Somebody gives a limit, x approach equal to 0, and they give you square root of 2x squared plus 4x minus 1. So what happened, I can say this, I can put the limit in. Limit, and then I can put the root in here. Limit 2, x squared, x equal to 0, and then plus limit 4x, x approach equal to 0, and there we go, minus limit x approach to 0 for the 1. So, see, that's what they say. Where n is a positive integer, we know here is 2, even if they don't give us. You know what I'm saying? But for odd, it might give another. So it all depends. And they say for that case, we assume that this is greater than 0. They just assume, like what I'm going to get here is going to be greater than 0. They just assume. They assume it's not, it must be. Okay? Let's take here, for example, like my situation. If you put 0, it's going to be 0. Plus, you put 0, it's going to be 0. And this is going to be, this is not going to have an effect. So it's going to be plus 1, minus 1. See, so this is not going to work for me. Because you know why? Because I didn't, my question was not right. Because my assumption was, it came as a, the function is less than 0. Because it's going to be negative 1. And this function here is, this function is less than 0. You know what I'm saying? So I should have taken another function, let's say plus 1. So if you plus 1, yes, I mean this f of x is greater than 0. So this is not something like major what, they know what else. So what you do most of the time, try to taste and plug the number. Hey, we're out, man. We're done. Thanks a lot, man. I'm out. So listen, you FaceTime, make sure you subscribe right here. You with FaceTime, subscribe right here. Easy, man. I'm out.